Hi everyone, welcome to the lecture series on applied mechanics. In the present lecture, we will be talking about the friction unit, wherein we specifically discuss on the ladder problems. So, if you look at the problem of a ladder, for example, determine the minimum force P to prevent, this is the ladder, minimum force P to prevent a 30 kg rod AB from sliding. The contact surface B is smooth, that means here in the ground smooth, whereas the coefficient of static friction between the rod and wall is 0.2. Here is the friction is there. Now how much amount of force need to be applied? This is a question. Now for all the ladder problems, very simple, we need to draw the free body diagram of this rod. In this case it is a rod, or I can consider this to be a simple rod. It also can be a ladder. So if I try to draw the free body diagram of this rod, it is something like this. It's a blue area. Now this rod is touching at the ground at B, right? B, so B will have a reaction which is normal reaction vertical, right? And I am also applying a P force this side, and this rod is touching on the wall. Now it will have a normal reaction, normal to the surface. Normal means perpendicular to the wall. Wall is vertical, perpendicular is the horizontal. Now apart from that, there is one more force, which is friction force. Now the friction force is Fa. So the friction force direction is important. Now for a direction of friction force, we need to know what is the direction of the motion. The rod has a tendency to slide down, that means it will come down, a point will come down. So the opposite of that motion of the point or body is the friction force direction. So this A will come down, the friction force is upward. Now we understand at this point A there are two forces, one is NA left hand side, FA vertical upward, and NB upward, and P is the right side. Now he said that 30 kg rod, we assume the G is 10, so 30 into 10 is 300 Newton is acting at the centroid, and we know this rod is having the 5 meter long, right? So is written here 3 meter is height and 4 meter is the horizontal distance. So the length will be 4 square plus 3 square under root will be a 5. So load weight is acting at the centroid, which is center of the length, which is 2.5. This side from here up is 2.5. This is basic we have to understand. Okay. Now how to solve? Simply we need to assume that G is 10 instead of 9.81, I can take G 10 meter per second square. It is gravitational constant. Now simply we have to use three equilibrium equations, right? So which is summation Fx equal to 0. For that I have already taken the free body diagram of this rod. So there is a ladder, I can say is a rod, right? I can assume this to be I can write this as also a rod, because mentioned here as a rod. Okay. Now summation Fx equal to 0. So what is summation Fx? Summation of all the forces in x direction in the entire ladder, right? How many x direction? One is the P is there, second is NA is left side. So P minus NA, P minus NA equal to 0. That means P equal to NA. So right now I don't know NA. So let us go to the next equilibrium equation, summation Fy equal to 0. That means what are the force vertical direction? One is your NB, second is FA. Right? Both are same direction. So NB plus FA equal to, that is vertical, and 300 Newton is downward, which is minus. So NB plus FA minus 300. Sorry, here the typing mistake. So you need to write down as 300. I will write down. So 300 equal to 0. Now next one, we have a friction equation. Which is Fa, friction force, is equal to mu times N. So at this point friction is there. So friction coefficient, static friction coefficient times normal reaction. Right? Here friction given as 0.2. At this point there will be friction, but since mentioned surface is smooth at B, so friction is 0. Okay. Now simply substitute Fa as a 0.2 here and here. Right. So then another equation is summation of all the moments at this point or this point equal to 0. So let us say I take moment at the point B. If I take moment at this point, right? So if I take at this point moment, what happens? So I have these two forces will have zero moment. Only 300 into this distance, and NA into NA is horizontal, perpendicular distance is this vertical, which is 3 meter, and friction force is vertical upward, and horizontal distance is this. This is also equal to this, right? So let us write down MB. So 300 into 2, which is clockwise, and NA into this distance, which is anti-clockwise. NA into this distance, which is anti-clockwise, which is, this is 3. So NA into 3. Friction force F into this distance, which is 4 meter, equal to 0. So I know FA is 0.2 NA. So 3 NA, 0.2 NA, so 3.2 NA, right? So equal to 600, right? 600 minus 3.8 NA equal to 0. So NA becomes 158 Newton. So hence NA is known to me, I can find FA, or directly NA is known to me, I can find P, which is NA. So P equal to NA equal to 158 Newton. Very simple. So let us solve one more problem like this. So this is a problem where a 80 kg man climbs up the ladder and stops at a position shown after he senses that the ladder is on the verge of slipping. He is climbing, somewhere he is sensing, his sixth sense says I may fall down. So it's verge of slipping. So determine the coefficient of static friction between the friction pad, that is here he has provided friction pads, and the ground, on the ground, if the inclination of ladder is theta is 60 degrees. This theta he has provided with a 60 degrees, and the wall at B is smooth. That means here there is no friction. Wall is smooth, so there is no friction. So friction is only here. The center of gravity of the man is at a G. G point is mentioned here. That means if length of the ladder is 3, so G is written here. Horizontal distance of the G is 1 meter from the wall. Neglect the weight of the ladder. Let us say ladder is weightless. So let us, this is what we need to find out, which is friction coefficient I need to find out, right? So G I assume as 10 meter per second square, acceleration due to gravity. So 80 into 10 is 800 Newton, right? Now I know this, if I say this is O, OA, So let us say I have a free body diagram here, that this is the rod AB is my rod here, the length given as 3 meter, okay. Length is given as the 3 meter, and also the man standing here, which is 800 Newton, is at a distance of 1 meter. So what I need to find out is this OA. Since angle is given to me, right, and the hypotenuse given to me, in order to find the base, I use cos theta, right? I can find cos theta. So anyway, that's required. We will see that. So now let us use these 3 equilibrium equations what we need to use for the ladder problem. One is summation Fx equal to 0. So all the forces in x direction equal to 0. What is x direction force here? Look at here. The ladder is having tendency to slip. That means it may go this direction, horizontal right side, right? Right. Then movement is right hand side, so friction force is left hand side. So there are 2 forces here. One is normal force NA and friction force FA, left hand side. And since the ladder is touching the wall, so wall will give a reaction NB. Okay. So what are the horizontal forces? Here is one FA, which is left hand side, so minus FA. NB is right hand side, right? NB. So simply NB minus FA equal to 0. This is simple. 1 summation Fx equal to 0. Very simple. There are no inclined forces here. Most of the ladder problems we don't have a inclined forces. Very simple. Next, summation Fy. Here there is no y direction force. Here Na is there. Here 800 is there. Very simple. Na minus 800 equal to 0. Na minus 800 equal to 0. That means Na equal to 800. Right? Now, we also have a friction equation, which is Fa is nothing but my mu times Na. So mu is given to me as, I have to find out the mu. So Na is known to me is 800. So Fa I can find out. Okay, and fine. So one more equation I have to use, summation m equal to 0. I can take m at this point or at this point, but it is easy for me to take m at this point, right? So this is anyway NB is mu Na, that because I know here. So summation Ma equal to 0. That means what are the forces apart from at A? This is one force, this is another force. That 800 into this distance, which is anti-clockwise, NB into this distance, which is clockwise, like this, right? NB into this distance, it's a clockwise, right? So NB into this distance is also equal to this distance, right? So since I know this length, diagonal and angle, I can use sin theta, or since I know this 1.5 and angle, I can use tan theta, 1.5 tan 60, so which is 2.6. So NB into 2.6 or 1.5 tan 60, I can write this as a tan 60 also. This entire thing I can write as 2.6. Then I have 800 into, this is total is, I can find out, I have already had 1.5, so that is coming from here OA 3 cos 60, which is 1.5. 1.5 minus 1 is here 0.5. So 800 into 0.5. So solving this, I get how much? NB is 151. So once I know NB 151, Na is known to me. So 151, this is 800. So mu will be simply NB by Na 151 by 800, which is 0.19. This is coefficient of static friction. Very simple. So this is second variety where I can find coefficient of friction. So let us see one more problem. This is a uniform ladder weighing 100 Newton and 5 meter long. Here, this is a ladder. Man is climbing. See, he is not holding hand. Okay, 5 meter long, has lower end B resting on the ground. So lower end is resting on the ground here, and upper end A is resting against the wall. Okay. The inclination of the ladder with the horizontal is 60. That means this angle is given to me as a 60. If the coefficient of friction at all surfaces of contact, that means this is a one surface of contact, here is another surface of contact at the wall. So at both the coefficient of friction is 0.25. Determine how much distance up along the ladder, means along the ladder. He is climbing, somewhere he will slip and fall down, right? Up along the ladder, a man weighing 600 Newton can ascend without causing it to slip. So it means basically at how much up he will go without falling down. Okay, very simple, nothing. Just take the ladder and draw free body diagram. Okay, like this. Take the free body diagram of this ladder. Very simple. See here. Now this is also rough surface and here also rough surface. So here vertical reaction, normal, ground is horizontal, the normal will be vertical. NB, because B point is there. Since ladder may slip, which direction? Downward. That means the right hand side may slip, because the ground is there, so it cannot come down. It has to go right hand side. So friction force is left hand side. So here I can write this is nothing but my FB. Similarly, the ladder is also resting against the wall, so wall is vertical, so my normal force is horizontal, and the ladder slips down, right? Here at this point comes down, so friction force is upward up. So this is also I can write as FA. Okay, I can write, or directly I can use mu NA. Okay. Now what are the forces here? NB, FB, FA, right, and NA. Then the weight of the person, which is 100 Newton. Sorry, 100 Newton is the ladder weight, and person weighing which is 600 Newton. But we don't know at what height he is climbing, at what point he will fall down. So I will take D is the height at which he may climb, after that he will fall down. So I need to find out this D, right? I need to find out this D. So since ladder length is given as 5 meter, so the weight is acting, ladder weight is acting at the middle height, which is 2.5 meter from the top and 2.5 meter from the ground. Okay. Now since angle 60 is given to me, so I need to find out the horizontal and vertical distances. So this, the 600 where man is climbed here, assuming that at a distance D, so this becomes D cos 60 because horizontal distance towards the angle, and this horizontal distance where the self weight of the ladder is acting, which is 2.5 cos 60, and total horizontal distance of the ladder is 5 cos 60 because total length of the ladder is 5 meter, and vertical distance is 5 sin 60 because away from angle. So since I drawn the free body diagram, I know the forces. Simply use again 3 equilibrium equations: summation Fx equals 0, summation Fy equals 0, summation M equals 0, and use friction equation, which already I have mentioned here, 2 friction equations. So summation Fx equals 0, taking a ladder, very simple. All the ladder problems, we have only 3 equations and finish, you get a full marks of the problem. Summation Fx equal to 0, that means all the forces in x direction. What is that? NA is there, x direction, and FB is there. That's all, only 2 forces. NA plus, and which is mu times NB left hand side, which is FB, right. So mu is given to me as 0.25, I use 0.25 NB equal to 0. Next, Fy, summation Fy. What is Fy here? Positive direction, mu NA is there, here NB is there, minus 100 is there, minus 600 is there, right. So NB minus 600, minus 100, then NA is upward, which is taken a positive, so 0.25 NA, which is friction force, right. One more equation, what is that? Summation moment at B point 0. So now these forces will not have any moment, only 1, 2, 3 or 4. Okay, so we can start with NA into this distance, right? NA into this vertical height, which is 5 sin 60. Okay, NA into 5 sin 60. Then mu NA, that is 0.25 NA, this vertical force having horizontal distance. What is this horizontal distance here up to the point B, which is this, which is 5 cos 60, which is 5 cos 60. Then what else? Which is 100 into this distance, which is what? 2.5 cos 60, 2.5 cos 60, which is anti-clockwise. Again 600 into d cos 60, 600 into d cos 60 equal to 0. Very simple. Now simply substitute here all variables into single variable. Right? Here what we get? NA and NB. Here NA and NB. Solve them. Right? Get into one NA and put it NA here. I can find D. Simply getting it a D. So solving 1 and 2, I get NA, which is 0.25 NB. Right? Then NB is equal to 700 minus 0.25 NA. So NA will become 165 Newton, and put it here and allocated D, right? D is equal to 2.3. So after climbing at a 2.3 meter distance, not even half also, 2.3 meter, if he goes 1 centimeter up, he will fall down. Okay, so this is what this problem meaning by very simple. Simply we need to draw the free body diagram is 1, then write down the distances, angles and so on, and then write the 3 equilibrium equations. That's all, simple. So let us solve one more problem. Okay. Now the uniform 10 kg ladder here. A uniform 10 kg ladder shown in figure rests against the smooth wall at B. So at B wall is smooth, that means friction is not there, and rest at an A on a rough horizontal plane, as I told you in the first problem. Here rough. Then for which the coefficient of static friction is 0.3. Here is 0.3 coefficient of friction. Determine the angle of inclination theta. So far we found out mu, coefficient of friction, we got horizontal force, and we got the reactions. Here now we have to find out the angle of inclination of the ladder and the normal reaction at B. How much is the normal reaction B if the ladder is on the verge of slipping, about to fall down? So simple, you just draw the free body diagram of the ladder, simple like this. And since friction is there here, I have a normal reaction because the ground is horizontal, normal reaction is vertical, normal reaction vertical NA. Since this ladder may slip and goes to the left hand side, so your friction force will be right hand side, right? And ladder has a weight of 10 kg, so 10 into 10, which is 100 Newton. So G I am taking as 10, and here since friction is not there, smooth wall, friction force is 0 here. So normal reaction coming from wall is vertical, so normal reaction is horizontal NB, right? So theta we have to find out, very simple. So simply summation Fx, summation Fy, summation F equals 0 gives me what? X direction forces, which is Fa and Nb. Fa means 0.3 Na, 0.3 Na minus Nb equal to 0. That is, let's say equation 1. summation Fy, which is Na minus 100, this is anyway 0, right? Na minus 100 equals 0, that means Na is 100. If Na is 100, Nb will be 30, right? Again, take the moment at A. So we have 100 into 2 cos theta, Nb into this distance. What is this distance? 4 sin theta, because theta is angle. So I know the length of the ladder is, that is called hypotenuse, 4. So opposite always 4 sin theta. Adjacent is cos theta, opposite sin theta. So 100 into this distance. 100 is vertical force, horizontal distance is 2 cos theta. Then Nb is horizontal force, vertical distance is 4 sin theta, right? So Nb is 30, put it here 30, right? So sin theta by cos theta equal to 200 by 120, which is theta is 59 degrees. So theta is tan inverse of 200 by 120, I get a 59 degrees. Over. Problem is very, very simple. Okay. So then he is asking normal reaction. Normal reaction means Na and Nb. We found out. Na is 100, Nb is 30. So he is asking normal reaction at B, that means Nb. We already got it. Very simple. Thank you.